Hey all, welcome back to my channel. In this video, we are going to understand what is layer 2 and layer 3 ether channel. So let us understand by an example. Let's say we have two switches and there's only one cable between two switches. Do you think if lots of end devices trying to communicate, this cable will able to load balance? No, it is not the case. It will blown up if too much load will be given to this cable. So that is the need of ether channel. And let's say if we try to put three cable within this switch, then also STP, spanning tree protocol, will be blocking two of the non-root switches. That means only one cable will be using that time also. So we need to implement the grouping of these three cable to consider it a one cable, one logical cable, and that is what ether channel is. If you connect, so understand point by point, if you connect two switches together with multiple links, all except one will be disabled by spanning tree. Means if this is our root switch, then these three ports will be our forwarding ports. So there is no problem with this side. But here only one root port will be there, only one forwarding port, and these two will be unutilized. So we need to implement ether channel. If all the excess layer switch means this switch were forwarding, layer 2 loops would form between both the switch, leading to broadcast stop. And let's say if all the interface are up and running, then also there will be a broadcast storm. Means the looping will occur, which what it will do, the broadcast storm will happen. What is broadcast storm? Broadcast storm is whenever, let's say this switch try to send data to this link or some server here on the which is connected on distribution switch. Let's say one ether frame is coming and it is going to all the ports, and that way the traffic which is destined to this server will be going through all the ports, and that way it will be broadcast, and this way all the cable will be facing the ether frame. That is not convenient. And other link will be, third point is other link will be unused unless the active link fails. And yes, there are chances, for example, when we implement all the cables and these three on the root switch will be unutilized, as I said. So there are the needs, these are the needs of ether channel. So ether channel is also known as port channel, and there are layer 2 ether channel and layer 3 ether channel. ओके, सो ईथर चैनल कुछ नहीं, बहुत सिंपल है कि दो स्विच के अगर बहुत सारे केबलिंग कनेक्ट हो रही हैं, अगर 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 हम उसमें कनेक्शंस को पास करते हैं तो कुछ पोर्ट्स जो हैं अनयूटिलाइज होते हैं, कुछ केबल अनयूटिलाइज होते हैं बिकॉज ऑफ स्पैनिंग ट्री। तो उसको यूटिलाइज करने के लिए हम उसको ग्रुपिंग कर देते हैं केबलिंग की, विच इज़ कॉल्ड ईथर चैनल। और इट कैन बी इन लेयर 2 में भी हो सकता है, इट कैन बी इन लेयर 3। लेयर 3 में होगा तो राउटिंग इनेबल हो जाएगा, both side we will be giving some IPs. But if it is layer 2, that means it is in LAN connection, it is within switches, and we are utilizing layer 2 things there. Let's see what are the in detail. Okay, so understand, if this is our access switch, means end device is connected to this switch, and we have a ether channel here. Let's say this is ether channel 1 where we have grouping. So now understand what is the use of ether channel load balancing. Ether channel load balancing work on the base of flows. For example, if any uh, data coming from this PC is going through this cable, it should follow some consistency, right? For that purpose, it should not be like one frame going through this cable, second frame going through this cable. If once ether channel created for within these switches, so for maintaining the flow, we use load balance, because if one frame is going this way, one frame is going this way, there will be a high possibility that it will go out of order. The frame will go out of order. In that, so we are utilizing ether channel load balancing conditions methods to make sure that everything is happening according to our uh, load balancing method. So there are six type of load balancing method as mentioned here. Source MAC address. Let's say in this let's understand this in detail. Let's say these are two switch, and I have four cable connected to this. This F01, F02, F03, and there are end devices. And so let's say this is the end devices with 000 DA MAC address. Okay, this is the MAC address. I want to implement this load balancing method that in this interface and with this port channel group one, I should be uh, I should be load balanced with the method of source MAC address. Means only this port will be in running when this source MAC address trying to send ether frame within this switch. So the command for this is, let's say, interface F01 port channel load balance. Method is what? Method is our source MAC address. So this command we will run to load balance, and this can be replaced by any other method which has mentioned here. So to restrict the flow of fame with respect to these method, we implement an ether channel load balance. I hope this is I hope you understood this. So ether channel load balance कुछ नहीं होता, एक मेथड होता है एक ये केबल को यूटिलाइज करने के लिए ईथर चैनल के अंदर या सेट ऑफ रूल्स बनाने के लिए जिससे कि सारे ईथर चैनल के केबलिंग पे इक्वल या फिर आपका डिफरेंट डिफरेंट अमाउंट ऑफ लोड पड़े. दिस इज कॉल्ड ईथर चैनल लोड बैलेंसिंग. Let's understand how many types of ether channel, layer 2 ether channel protocols we have. There are two types of protocol, dynamic and static. In dynamic, we have two, PAGP, LACP. PAGP is port aggregation protocol, which is Cisco proprietary protocol. This is Cisco proprietary. It is having two modes, desirable and auto. If desirable meet with any of the mode, the trunk or the ether channel will be formed. And if it is auto, that means no ether channel will be formed. This is a dynamic, and this we provide to an interface. And this is LACP, link aggregation control protocol. It is also dynamic, but it is multi-vendor supported, and it dynamically negotiate the creation and maintenance of ether channel. And it has two state. First is active, and the second is passive. Passive work like a auto, and active work like a desirable. So if an active meets with any of the mode, the ether channel will be formed. Else passive means no ether form. And there are a second way which is static, in which we just put on mode, and static ether will be formed. It is manually. So dynamic we have two, PAGP, LACP, port aggregation protocol, link aggregation control protocol. So these are two protocol which you need to remember in ether channel. So let's just understand in detail how do we utilize these. Let's say these are two switches, and they are having three cable connected to it. This is our access switch, this is our distribution switch. It is connected to three computer, and this is connected to one of our server, and one is our printer. Okay, so now understand. So how do we implement the ether channel with PAGP? First understand with PAGP. Let's say this is our F01, F02, F03. Same goes here. And this is 054, 0y5, here also 0y4, 0y5, 0y6. Understand? This board will be accessed, right? I mean, there is nothing going to happen in this. But configuration which we are doing according to PAGP will be here. So understand. The interface range F01 to F203, F01 to 03. We are going to create a channel. Channel group. This command we will run. Channel group 1 mode. In PAGP it is auto or desirable. We can choose auto or desirable. If it is LACP, we will use passive or active. And the moment we put channel group 1 mode desirable, this command we will run in this switch as well as this switch. The moment we do it, our ether channel will be formed with the name 1, ether channel number 1. And the moment ether channel form, we can change its setting by going into the interface port channel 1, switch port trunk encapsulation.1q if it is LACP, and otherwise it will be utilizing ISL, and switch port mode trunk. This command we will run after that. And the moment we do it, our port channel is start working. It will all the ports will be a forwarding. There's no looping, nothing, and in that way we utilize lots of physical links with one logical link which is called ether channel. So ether channel is an aggregation of physical links between switches to optimize the physical cables reliably. And there are two commands for troubleshooting to know about ether channel. We will be seeing it in the practical. Now let's just understand what is layer 3 ether channel. Layer 3 ether channel is nothing different than layer 2 ether channel. But here we have including layer 2 ether channel plus IP routing. There's nothing going to happen in terms of ports now. Everything will be going to happen with a single port, not ports. It's a single port with IP. So that means both sided we will be. So by logging into port channel, we are going to add the address in this switch one, this access switch. We are going to assign this address. Let's say 10.0.0.1, and by logging into this switch, same port channel, we will be giving it 2. And this is the same way as layer 3. What is the use of this? It is sometime what happened in layer 2 ether channel. In layer 2 ether channel, we try to confuse with the IP addresses. In layer 3 ether channel, we are utilizing IP addresses. Routing will be enabled. In that way, it will work more significantly. Now let's just move to our practicals. So let's say we have two switches and two devices connected this side, two devices connected this side with these IPs. Right now, as you can see, spanning tree has enabled, and this switch has been elected as root switch, and in that way, all the ports are working. But here in the non-root switch, only one port is forwarding, else is blocked. So we are not utilizing all the cables. We are just one cable is getting utilized. All other are on backup. But Ether channel, what Ether channel will do? It enables all the port to forwarding. For example, it is showing here orange, right? That means this port is blocked. So we are going to implement it this Ether channel layer to Ether channel. So let's just do it. So enable config T interface range F03 to 5. We are going to create one channel group 1 mode desirable. See, desirable will create a ether channel. So all the ports are running, and now config T interface port channel 1 switch port mode trunk and okay, switch 1 is done. Now switch 2. Here also we'll create the same way on sorry config interface range F03 to 5 channel group 1 mode desirable channel group 1 mode desirable and quantity interface port channel 1 enter switchboard mode trunk. Okay, enter. Now as you can see, I'll just fast forward it. Do you see some change? How now all the ports are forwarding because we have created one ether channel here, layer 2 ether channel. In that way, we can also load balance as I explained earlier. Load balance with different IPs, different source IPs, and source MAC address, destination MAC address. Like how we are going to utilize each and every cable in this ether channel, but that is far. This will go far in detail, but no. Right now we are focusing on how to create ether channel. This is the way. Command I have already shown. You can copy and paste and work along it. Now we'll check the connectivity. So this is IP address 10.1.1.3. So I'll open my laptop on switch 1 and I'll check it. Ping 10.1. Yeah, it is working. Same way I'll go ping 10.1.13. It is also working. So this is the end-to-end connectivity through ether channels. Right now, as we are, any of the cable is getting utilized here, but once we apply load balancing, this will be in that way we will be using. We can able to use multiple or selected cables in that ether channel. So I hope you understand basics of ether channel, layer 2 ether channel, layer 3 ether channel will be same way, but we have to assign the IP addresses, and that's all for today. Thank you so much for watching this video. I hope if you like it, please subscribe my channel.